Hi, welcome to Extranets Networking Training again, concepts and importance of data network. In this video, we will see the importance of networking, especially the internet, how it works and impacted human lives. After making my research, I decided to bring you some information from Cisco regarding data networking, and I hope it's going to be informative. One of the fascinating importance of networking is the elimination of barriers in communications. Advancement in networking technologies are helping create a world without boundaries. The immediate nature of communication over the internet encourages global communities. Cisco refers to the impact of the internet and networks on people, the human network. Looking at the way we learn, technology has improved a lot in our learning systems. Do you remember sitting in a classroom like this? You don't have to be in school anymore to take a classroom. You don't have to be in classroom to have a teacher. Data networks have evolved in helping support the way we work. Online learning opportunities decreases costly and time-consuming travel. Employees training is even becoming more cost-effective. Network also impacted the way we play. We listen to music, watch movies, read books, and download materials for future or offline use. Networks allow online gaming in ways that were not possible 20 years ago. So, you can see the importance of networking in today's world. Networks are in many sizes. You can have a network as small as a home network, or you can have a network as big as the internet or the worldwide network. Small home networks connect a few computers to each other and the internet. Small office or home office enable computers within a home or remote office network. We also have medium to large networks, many locations with hundreds or thousands of interconnected computers. Worldwide networks connect hundreds of millions of computers, such as the internet. A network can be as simple as a single cable connecting two or more computers, or as complex as connecting networks that span the globe. Now, there are three main components in a network infrastructure: devices, media, and services. Devices can be end devices or intermediate devices. Media can be wired or wireless, and services can be data, voice, video. End devices is where a message originates from, or where it is received. Data originates with an end device, flows through the network, and arrives at an end device. Intermediate networking devices can be wireless routers, LAN switches, routers, firewalls, or multi-layer switches. So these devices interconnect end devices in a network. The management of data as it flows through a network is also the role of an intermediate device, including regenerate and retransmit data signals. So when a signal is moving from the original point towards the destination, this signal will be losing strength as it travels across the network. So the regeneration of this signal and retransmissions is the responsibility of an intermediate device. The intermediate device is also responsible to maintain information about what pathways exist through the network and internetwork. For example, if I send data from my network, which is intending to reach another network in a different location, a router will be responsible to decide which way to send out this message. Intermediate devices are also responsible to notify other devices of errors and communication failure. The second component is the medium in a network. Medium is the path for data transfer. Communication across a network is carried through a medium which allows a message to travel from source to destinations. So if I want to send a data from one location to another, then this also goes through a medium. Like if I'm speaking to somebody who is standing in front of me, my speech, this sound will go through the airwaves and it will hit the ear or the recipient. Likewise, if you are communicating using, if you are communicating in data network, sending data has to travel through a medium like a copper, fiber optic, or wireless mediums. Network can be represented in two main categories. One is physical topology. Two is a logical topology. The physical topology is a physical representation of the network diagrams. This can quickly show us how the network is connected and how it is set up. So this includes where the devices are connected, where the routers are mounted, which rack, which shelves, which cable type is used, and so on. Whereas the logical topology can display further information like the IP addresses, the port numbers, and even routing protocol in use. These can also help understand the network data flow part as well as helps in troubleshooting. As we said earlier, we have different types of network like LANs and WANs, local area networks and wide area networks. So LANs spans a small geographical location such as homes, schools, office, buildings, or campus, usually administered by a single organization. So here you can see this simple network with few users and an intermediate devices here connecting other devices like a server. You can also have your printer here, network printer, and this is a telephone handset. One network connects two or more LAN networks. So here you can see we have two branch offices. Branch office number 1, which could be in city A, and branch office number 2, which could be in city B. So for example, if this was a bank, I can have my bank account open in branch 1 in city A, and I do a transaction in this same account in branch number 2 in city B. So of course, these two branches need to be connected, and the connection is done using a WAN link, usually through a service provider. So WAN interconnect LANs of a wide geographical area, such as between cities, states, or countries, usually administered by multiple service providers. WANs typically provide slow speed links between LANs. So this WAN link, most of the times, will be limited speed because it is very expensive to maintain this type of links. So usually you paid a service provider that can help you connect your multiple branches within a country or across cities. The Internet is the biggest WAN network. So we have the Internet, that is network of networks, or we sometimes call it the public network. We have Intranet and Extranets. The Internet is a worldwide collection of interconnected LANs and WANs. LANs are connected to each other using WANs. WANs are then connected to each other using copper wires, fiber optic cables, and wireless transmissions. The Internet is not owned by any individual or group. However, the following groups were developed to help maintain the structure: the IETF, that's Internet Engineering Task Force; ICANN, the Internet Corporation for Assigned Names and Numbers; IAB, the Interactive Advertising Bureau. So you can see the Internet actually has interconnected nodes or devices that can extend to other WAN networks and other LAN networks. So here you can see a government LAN, hospital LAN, home LAN, school LAN, business LAN are all interconnected together through the Internet cloud. So nobody owns the Internet, as we said, so you can either join the Internet or you disconnect from the Internet. There are different network platforms. Converged networks. Traditionally, networks were separated. What we mean here is you have a separate network for data, separate network for voice, and a separate network for video. This has been the traditional In today's network, we have a converging network. A converging network means we can have data services or the voice services and plus the video services integrated into the same network. Use the same circuits and use different devices and enhance communications. So you don't have to build a separate network for data anymore. In order to have a reliable network architecture, you have to put into consideration these following things. Network has to be fault tolerant. That means if one device in a network fails or one part, transmission part in a network fails, there should be a redundant one. A reliable network should have scalability. That means in case that you want to do any expansion on a network, you don't have to build the network from scratch. So you can easily add in your device or add in new branches, connect new sites to the existing network without much service interruptions. Security also needs to be considered in order to have a reliable network. Quality of service is also an important component in a reliable network. That simply means data traffic and voice needs to be treated differently. Data can wait, but if you have a delay in voice, if I am speaking and then my speeches had some delay, so the recipients or the one who is listening will have troubles interpreting what I'm saying. The changing in network environments. Network trends has changed even to the way we communicate in our work environment. For example, the Cisco telepreferences powers the way of working where everyone, everywhere can be more productive through face-to-face collaborations. This includes online meetings, workshops, and even training on the job. Technology trends in the home. We can see the importance of networking in our daily lives, and it is even getting more sophisticated, and the trend is now moving. Now with smart homes technology, ovens might know what time to cook a meal for you by communicating with your calendar on what time you are scheduled to be at home. You can be in your car driving from work to home and switch on your AC 10 minutes before you reach your house. Security is an important component, as we said earlier. So network security is an integral part of networking regardless of the size of network. Secure a network involves many protocols, technologies, devices, tools, and techniques in order to secure data and mitigate threats. Threat vector might be external or internal. Looking at external threats include viruses, worms, Trojan horses, spyware, adware, zero-day attacks, hacker attacks, denial of service attack, data interception, and theft. You need to get a mind picture of how the internet works. Watch this from Warriors of the Net.
For the first time in history, people and machinery are working together, realizing a dream. A uniting force that knows no geographical boundaries without regard to race, creed, or color. A new era where communication truly brings people together. This is the dawn of the net. Want to know how it works? Click here to begin your journey into the net. Now, exactly what happened when you clicked on that link? You started a flow of information. This information travels down into your own personal mailroom, where Mr. IP packages it, labels it, and sends it on its way. Each packet is limited in its size. The mailroom must decide how to divide the information and how to package it. Now, the package needs a label containing important information such as sender's address, receiver's address, and the type of packet it is. Because this particular packet is going out onto the internet, it also gets an address for the proxy server, which has a special function, as we'll see later. The packet is now launched onto your local area network, or LAN. This network is used to connect all the local computers, routers, printers, etc. for information exchange within the physical walls of the building. The LAN is a pretty uncontrolled place, and unfortunately, accidents can happen. The highway of the LAN is packed with all types of information. These are IP packets, Novell packets, Apple Talk packets. They're going against traffic, as usual. The local router reads the address and, if necessary, lifts the packet onto another network. The router, a symbol of control in a seemingly disorganized world.
Whoops, sorry about that. Let's go with this one here, this one here. This one goes here, this one goes here. I don't like this one. Let's go with this one. Let's go here. A little bit left. Let's go with this one here. Another channel here. Let's put that one here. Another one there. Let's put that one here.
There he is, systematic, uncaring, methodical, conservative, and sometimes not quite up to speed.
Sorry.
But at least he is exact, for the most part.
That's the one goes there. That one goes there. That one goes there. That one goes there. And this one goes there. Oh, another one goes there. That goes there. He's behind him. Let's go there. That goes there. He goes there. Oh, let's put that one there.
As the packets leave the router, they make their way into the corporate intranet and head for the router switch. A bit more efficient than the router switch plays fast and loose with IP packets, deftly routing them along their way. A digital pinball wizard, if you will.
Here we go. Here comes another one. And it's another. Watch this, Mom. Here goes. Whoop, we're on the back. Hey, in there, in there, in there. Over the left, over the right, over the left, over the right. You got it. Here it comes. Right on. He shoots. He scores. It's going. Hey, wait. Here, watch out. Here comes another one. Oh, here we go. And it's gone. It's gone.
As packets arrive at their destination, they're picked up by the network interface, ready to be sent to the next level. In this case, the proxy. The proxy is used by many companies as sort of a middleman in order to lessen the load on their internet connection, and for security reasons as well. As you can see, the packets are all of various sizes, depending upon their content. The proxy opens the packet and looks for the web address, or URL. Depending upon whether the address is acceptable, the packet is sent on to the internet. There are, however, some addresses which do not meet with the approval of the proxy, that is to say, corporate or management guidelines. These are summarily dealt with. We'll have none of that. For those who make it, it's on the road again. Next up, the firewall. The corporate firewall serves two purposes. It prevents some rather nasty things from the internet from coming into the intranet, and it can also prevent sensitive corporate information from being sent out onto the internet. Once through the firewall, a router picks up the packet and places it onto a much narrower road, or bandwidth, as we say. Obviously, the road is not broad enough to take them all. Now you might wonder what happens to all those packets which don't make it along the way. Well, when Mr. IP doesn't receive an acknowledgement that a packet has been received in due time, he simply sends a replacement packet. We are now ready to enter the world of the Internet. A spider web of interconnected networks which span our entire globe. Here, routers and switches establish links between networks. Now, the net is an entirely different environment than you'll find within the protected walls of your LAN. Out here, it's the Wild West. Plenty of space, plenty of opportunities, plenty of things to explore and places to go. Thanks to very little control and regulation, new ideas find fertile soil to push the envelope of their possibilities. But because of this freedom, certain dangers also lurk. You'll never know when you'll meet the dreaded ping of death. A special version of a normal request ping, which some idiot thought up to mess up unsuspecting hosts. The paths our packets take may be via satellite, telephone lines, wireless, or even transoceanic cable. They don't always take the fastest or shortest routes possible, but they will get there. Eventually. Maybe that's why it's sometimes called the World Wide Wait.